Hello and welcome to the YouTube channel of Canara Engineering College, Mangalore. In this video session, we will learn regarding voltage regulators, which is one of the very important applications. So basically, in order to know what are these voltage regulators, we need to know what is the need of this voltage regulators, how basically are this particular voltage regulators functioning. So let us check out what are these voltage regulators. So when we speak about voltage regulators, normally there are some applications which require DC voltage or current as output, or there are a lot of applications which will be requiring DC current or voltage. This DC current or voltage is basically obtained from the AC source what is available at our workplaces or at our homes. So once you convert this AC to DC, the DC voltage or current what is available at the output side normally should be constant. We expect the voltage what is available at the output side to be constant, or it should be free of your ripples, what we call it as disturbances or noises. This ripples or noises what is produced in this DC will be because of the applied voltage or varying applied voltage or varying load current, or maybe because of the variations in the temperature. So as it is said here, all electronic systems that we use in our day-to-day life will be requiring a stable DC power supply or voltage source, and the voltage regulators can be performing this function of supplying you a constant voltage or constant DC power. So voltage regulator is a circuit that keeps the output voltage constant under all operating conditions. So when we speak about this operating conditions, by operating conditions may be with respect to the temperature, it may be with respect to the varying input, or it may be with respect to the varying load. In spite of this various operating conditions, I expect the DC source to be giving, or the DC voltage source to be giving, a constant output. Normally these devices are called as voltage regulators, and this voltage regulators can be categorized into series voltage regulators or shunt voltage regulators based on the construction or based on the way in which it has been constructed to give the constant output. Moving on further, let's check out what is the need of these regulators at this particular hour. So normally in practice, in our day-to-day life, there will be a lot of fluctuations in voltage that is caused by external factors. External factors may be due to variations, due to faults, or due to various other things. This faults or variations can change the DC output voltage. But most of the devices what will be working on the DC voltage sources will refuse to work satisfactorily under such varying voltage conditions. For example, if you say you have a device which will be working under 5 volt, maybe at the maximum it will work at 4.8 volt, or it may be working at 5.4 volt with this much range. Suppose if the voltage falls beyond this, or if the voltage goes beyond this, the device which will be working under 5 volt will refuse to work satisfactorily. It means that the device might function, but it will not function efficiently. So hence regulated power supply is the need of the hour. So that is why we need to be having voltage regulators. So why these variations can happen, or what are the reasons for these variations in the output or in the output of a source? So internal resistance of the ordinary power supply is relatively large. Therefore, output voltage is affected by the amount of load current drawn by the supply. So one of the reason what might be affecting the constant output DC voltages, variation of the load current which is drawn from the supply. This variation in the load or DC voltage may cause erratic operation of the devices or of the circuits. Without stable potentials, circuit performance degrades, and if the variations are large enough, the components might get destroyed. In order to avoid this, regulated power supplies should be used. In simple words, the device what I'm going to use will work efficiently only if a constant DC supply is being supplied to it. Suppose if the DC supply is having variations in the voltage or if it is having variations in the currents, normally the device what has been connected at the load end will be performing erratically, or the performance of this particular device will not be efficient. If the variation is large enough, if the variation or if the variation in the output of this particular DC source is large enough, then there are chances that this device might get damaged or destroyed permanently. So what you need to do is you got to make sure the DC output what is coming from this DC source will never undergo variations. This variations can be avoided by using voltage regulators. That is why we need regulators here. Normally in case of our day-to-day life, we will be having AC power supply as input. This AC power supply will finally be converted into output. You might see in case of your LEDs, or you might see in case of your some devices which will work purely on DC, then normally you will not be having a DC source. You will be having a AC source. That AC source will be converted into the required DC power output. So this is a general block diagram how your AC will be getting converted into DC. So normally you will be having a transformer which will be fed with an input of 230 volt 50 hertz, which is a normal supply. Then that power supply will be converted, or it will be degraded, or it will be downgraded to the required voltage, or you can say it is stepped down to the required voltage. After being stepped down, it is fed as input to the rectifier. So what does your rectifier do is rectifier will be converting your negative cycle to positive cycle. So rectifier will be doing that particular function. The output of the rectifier is given to the filter so that any ripples or any unwanted signals or noises that are present at the output of the filter output of the rectifier will be removed by the filter. So you can see here, this is the output of your rectifier. After it has been given to the filter, you can see it as some of the noises or a part of the output of the rectifier is being terminated here. This output of the filter is given to the voltage regulator, where the regulator will be converting the output of the filter, which is having ripples and which is having variations, to regulated DC output. The output what you can see here is having no variations, which means that regulator will be regulating the voltage to the required DC level. So there are multiple stages that you can see here, but basically my regulator will be playing the last role in making my DC voltage constant and smooth. And this has to make sure that no matter whatever changes happen in the input, or no matter whatever changes happen in the load, or no matter whatever changes happen in the working conditions or operating conditions, this regulator should be able to give a very smooth regulated DC output. That is what is the function of your regulator. So what are the factors that generally affect the load voltage? So we need to check what are the general factors. So normally when we speak about your regulator, we expect the voltage regulator to be giving the constant voltage, right? We need to check out, or we need to see whether the voltage that is given by the voltage regulator is constant or not. If it is not giving the constant or smooth DC voltage, we need to check what may be the parameters that is not letting the voltage regulator give the smooth voltage. The first parameter here is load current. The first parameter what will stop the voltage regulator from giving the smooth DC voltage is load current. Load current normally is the current what is drawn at the load side. So for example, if you say this is your voltage regulator, if you say this is your voltage regulator, so let us say this is your DC source, okay? Let us say this is your DC source. The output of this DC source might be connected to some load. It may be connected to any load. So when I say I am connecting any load, this load is going to draw the current. This load is going to draw some current. But what might happen is, in some cases, the load what you have connected might increase. It might increase or it might decrease depending on the requirement. When the load that you have connected here increases or decreases, it normally varies the load current. This load current will normally vary the output voltage, or this will normally vary the voltage what is being drawn at the output side. So ideally the output voltage should remain constant. Ideally what I expect is, this DC source should be giving a constant output voltage in spite of varying load. But practically the power supply without regulator, if there is a power source without a regulator, this load voltage will vary with respect to varying load. When the load voltage varies with respect to varying load, then normally I can say that the output voltage or the output current is not smooth. So what you can do here is, you can connect a regulator at the output of the DC source, and this DC or the voltage regulator what you can see here will be making sure that in spite of varying load, the voltage or the output voltage will not be varied. That is one of the important factor which will be affecting the load voltage, or load current is one of the important parameter which will be varying the load voltage. So you need to make sure that in spite of varying load current, the load voltage is not varied. So that can be done with the help of the regulator. Line voltage is nothing but the supply voltage what you are giving. It may be your AC. It may be your AC voltage what you are supplying. So normally when the load varies, load voltage will also vary. When the load voltage varies, it will be the supply voltage or the line voltage what you have supplied at the input side of the voltage regulators will also vary along with the output. So this normally affects the performance of the power supply. So normally I expect voltage to remain constant. Normally expect the output voltage to remain constant in spite of the varying line voltage. Temperature is one of the parameter which in fact affects the load voltage. How does it affect us? If you could check out the previous diagram, you had a rectifier here, you had a filter here, and you had a regulator here. All these particular rectifiers and filters are made up of semiconductor devices, or they are made up of diodes. Now when you say that the load current increases, obviously the temperature of the devices what make up a filter or what make up a rectifier will increase as per the load current. This variations in the temperature or this increase in the temperature of this particular semiconductor devices will affect the performance or will affect the load voltage. So these are the three important parameters which will be affecting the load voltage. The first one is the load current, the varying load current. Second one is the line voltage. The third one is the temperature. So these three factors play a very major role in affecting the load voltage. When I speak about load voltage, please remember this load voltage is nothing but the output voltage, or the voltage that is available at the output terminals of the DC source. Going on further, let's check out some of the performance parameters of the power supply. So when I speak about a DC power supply, there are various parameters which actually measure the performance of that particular power supply. The performance parameter of the overall power supply is judged by specifying some of the parameters called as performance parameters, and those performance parameters are the ones what we are going to check out here. The first one is line regulation. So remember, factors are different, parameters are different. Factors are entirely different. Performance parameters is I am speaking very strictly with respect to the DC source. When I speak about the factors, those factors are the ones which are out of your DC voltage source. Performance parameters are with respect or within the power source. So first point here to be known is line regulation. So let us say that let me say that the input voltage to the rectifier is 230 volt and the output DC voltage will change, and since the output of the rectifier is applied to the regulator, the output of the regulator will also vary. So it basically can be defined as change in the regulated DC output voltage for the given change in the input voltage. So line regulation can be defined as, it's a ratio basically. It's a ratio of change in the output voltage of a DC voltage source divided by the line voltage what is being supplied to that particular voltage source. Ideally, I expect the line regulation or line regulation to be 0, and practically it should be as low as possible. So you can write it as a ratio of VDC divided by VAC. This is what is line regulation. So it is defined as change in the regulated DC output for the given change in the line voltage, or you can write it like this: delta VDC divided by delta VAC. Change in the DC output voltage with respect to the change in the AC input voltage, or change in the output with respect to the change in the input. That is what is line regulation. Coming to the next parameter, which is load regulation. This is defined as, this line load regulation is defined as change in the regulated output voltage when the load current is changed from no load to full load. So load regulation means you are checking what is the change in the output voltage. For example, you take a power source, you take a DC power source and you connect a load. You connect a load here. So you check out what is the change in this DC output voltage when you connect no load to full load. So you connect a resistance or you connect a rheostat here. So you keep on varying the load from no load to full load. That variation in the voltage is called as load regulation. This percentage load regulation, normally the load regulation is given in terms of percentage load regulation, which is given by the ratio of variation in the voltage from no load to full load divided by the voltage at full load. So this is what is called as percentage voltage regulation. The graph what you can see here is the graph with respect to your percentage or load regulation. So you can see here the dotted ones are ideal. Normally I expect the output voltage of the DC source not to vary from no load to full load, that is the dotted one, but practically when you vary the load from no load to full load, obviously your output voltage will increase or it will vary or it will reduce. This variation in the output voltage will vary the load current, and this in turn might vary the temperatures also. So in order to avoid all these things, I was speaking about a voltage regulator. It is always better you connect a voltage regulator. If you connect a voltage regulator, probably the variation will not be so much. The variation will be only a little bit. It will not be so much. If you do not connect a voltage regulator, then obviously from no load to full load, the voltage at the output of the DC power source or DC supply is going to vary by too much extent. The next one is called as voltage stability factor. So this is one more factor which shows the dependency of output voltage on the input line voltage. So this is one more, this is actually a factor which says by how much value or by how much your output voltage is actually depending on the input line voltage. This is defined as a percentage change in the output voltage which occurs per volt change in input voltage, where load and temperature are assumed to be constant. So very similar to this one, very similar to load regulation. So you are just checking by what parameter, by what factor the voltage is varying from no load to full load. But you are going to make sure the load and temperature will remain constant. So that is what is voltage stability factor. Temperature stability factor. Temperature stability factor means you are going to check the variations in the output voltage with respect to the varying temperature. So normally in case of your power supplies, we will be using semiconductor devices, and the output voltage will obviously become temperature dependent. This temperature stability factor, that is what we are defining here, will be determined by temperature coefficients of various temperature sensitive semiconductor devices. So as the temperature varies, I need to check what is the change in the output voltage. But I always expect my output voltage to vary to the minimum. If you want your output voltage to vary to the minimum, you got to make sure the temperature of the semiconductor devices do not vary. So what you need to do is, you need to take the devices which are having very low temperature coefficients. Those low temperature coefficients will make sure temperature stability factor will be low, or it will be somewhere close to 0. Last one is ripple rejection factor. So ripples, as I said you, if you say this is your DC, normally your DC will be something like this. Your DC will be something like this. Irregularity in the DC. This irregularity is what you call it as ripples in the output. The output of the rectifier and the filter, the output which is coming from the rectifier will contain ripples, and this ripples will be removed by the filters. It is defined as a factor which shows how effectively the regulator will be rejecting the ripples. In fact, let's say this was your input to the filter, okay? Out of this filter it was something like this. Out of this filter it was something like this. Better than this one. Now once it is given to the voltage regulator, your voltage regulator will give a straight line. See here, it was being explained, right? See here, filters will be having a little bit of ripples. When it is given to the regulator, it becomes a smooth DC. So here, ripple rejection factor is defined as a capacity of the voltage regulator to reject the ripples. That is what is your ripple rejection factors. So these are the performance parameters of the power supply. So line regulation, this should be as low as possible. Load regulation should be as low as possible. Voltage stability factor, this also should be as low as possible. This one should be as low as possible. Ripple rejection factor should also be as low as possible. So all these particular things are with respect to your power supply, not with respect to your regulator. So if you want all these parameters to be low, if you want line regulation to be low, if you don't want your line voltage or line current to be affecting the output voltage, or if you don't want your output voltage to be affected by the varying load, or if you don't want your voltage to be affected by the parameters which with respect to your load and current, or if you don't want your power source to be affected by the temperature, or if you want your power source to be having a very smooth DC output, then it is always better at the output of the DC you connect a voltage regulator. The voltage regulator will take care of all these parameters, or it will make sure all these parameters will be as low as possible. It will be as low as possible. Moving on further. This is a circuit diagram, or this is a symbolic diagram of your regulators. Normally my regulators will be coming as 3 terminals. This is actually an IC, it will be coming as 3 terminals. So you can see the numbers are given LMMC 78XX, LMMC 79XX. So normally these are the series, and this XX actually indicates the regulated output voltage. So whatever input you can give the output from the filter, or you need to be giving the DC from here, that DC will be filtered by this capacitor. In fact, the capacitors what I have connected here, they will basically be functioning, or they will be helping me in removing out the ripples, and this is the one which is actually going to smoothen it, or this is the one which is going to make sure that variations in the output will not vary the power source. Even though there is variations here, input will not be varied, or even though there is variations at the input side, the output of this is not going to be varied. So this is how it is going to look like. So LMMC 79XX, LMMC 79XX. So basically these are the very popular 3 terminal voltage regulators. There is something called as adjustable voltage regulators also, which you can see here. Adjustable voltage regulators are the one in which you can adjust the output voltage. The resistors R1 and R2 determine the output voltage Vout. The resistor R2 can be adjusted to get the output voltage in the range of 1.21 volt to 57 volt, which means that, suppose if you are saying that, sir, I will be connecting various loads here, and the output what I am going to connect here, might be needing, or the output, the load what I am connecting here will require various output voltages. Can I use a single voltage regulator? Yes, you can use a single voltage regulator, but you got to make adjustments. You got to check what is the output voltage or voltage requirement of the device. Based on the voltage requirement of that particular device, you need to make the adjustments. And the circuit diagram for the adjustable voltage regulator is this one, where the output voltage is given by terminal voltage, right? VR into 1 plus R2 divided by R1 plus I adjustable, that is this current that is flowing divided into R2. So that is the formula. So based on, you can select the values of R2 depending on the output voltage. My VR is actually the voltage that is available across the resistor. This cannot be varied. I can vary only the current that is flowing through this particular variable resistor. So by varying this variable resistor, you can adjust the voltage of your choice as per the requirement of the load what you are connected. This is regarding your voltage regulators. Thank you.